So we begin with our given information. The given information is just relationships. It doesn't give you any specific equality of measures. Okay, so what we can do to build from this is to just interpret each of these statements. Okay, so the fact that BD is perpendicular to AC tells you they meet at what? They meet at a right angle, right? So you have two ways to approach this. You can approach it in terms of the properties. So what we could say is that angle ADB and angle CDB are right angles. Okay, and you can justify that because perpendicular is defined as segments that intersect at right angles. Okay, now if that's the way that you approached it, what you could then do to demonstrate that these two angles, not only are they right angles, but what do you know about all right angles? All right angles are equal. So, so we can take the measure of these two angles, ADB and CDB, and we can set them equal to each other. And the justification would be that all right angles are equal, one of the postulates that we started with. Right now, we could have achieved this result in a different way. If we had chosen to go a different route, we could have gone the route of equations, and we could have said, in terms of these perpendiculars will meet at what angle measure? Based on the fact that those are perpendiculars means that each of them would be 90 degrees. It would still be justified as definition of perpendicular. And if that was the method that we used to approach it, we'd still wind up with the exact same statement in step 3. Except what would our justification be for this? Here we have in green two things that are equal to the same thing, therefore they are equal to each other. And what's that justification? Transitive property or substitution. Okay, so either of those you could have performed either of those steps. Okay, regardless of that, we can now move on. We have this one pair of angles that are equal. Let's move to the other piece of information that was given, and that is that BD bisects angle ABC. So again, what that means is that it cuts this angle into two equal parts. So we can claim that those individual parts are equal. So that's definition of bisect. So now we have two pair of angles, so we need any other side. So any sides that we can show are congruent between the two triangles, and we're done. What's the easiest side to show? The side that's equal to itself. BD is a shared side, so reflexive property. Okay, and once you have this, you have two angles and the included side. That's enough to show that the triangles themselves are congruent. So ADB is congruent to triangle CDB. Two angles and the included side.